So, good morning, everyone. Thank you for being here. We all know that in modern software development, code readability plays an important factor in the overall code quality. But the question is that always the case? Do we always write readable code? Now, imagine for a while that you are in front of a computer screen as your peer or your colleagues types the code into the program. You have a little bit of context here. This is about managing items of a tree view. So obviously, there's this object tree view. And let's look at the first function that that program starts with. It says setState. This should ring an alarm a little bit, because state is such a generic word that setState could mean anything. It's very hard to deduce what state means for a tree item if you don't have any API documentation. Now, obviously, this function can accept some parameters, and apparently the first value is true. It's Boolean value. You start to get confused because setState true, what does it mean? How does it compare to state being false? Apparently, that's not the only values that this function accepts. Apparently, you can pass another value, which is false. So at this point, you totally fall into the dark side, because not only state is such a cryptic function name, if you combine two contrasting values for the parameters, it doesn't make any sense. The goal of this talk is very easy. It's very simple. I want to prevent you from being the next Darth Vader because of any frustrating API. So you may say that, well, I don't develop libraries, I just write application. But in normal practices, regardless what application that you build, you need to take into account certain good API. If anyone here have done Java programming or C++ programming, these are the two valuable resources that you can use when you develop your library API. Did I miss some slide? No. However, we know that JavaScript is not Java, so just like horse and horseradish, they are completely different. So the big question is, can we adopt some of the best practice that people have developed over the time in other programming language to JavaScript? So even if you just develop application, no library whatsoever, you don't use any third library, you don't expose any libraries. Apparently, because of modular architecture that we love so much, there will be interfaces between at least two functions, two objects, or even two modules and two files. Any kind of interaction between these two constitute an interface, and there you have to pay attention to the API. First of all, we all know that nobody reads API documentation. The way we develop program is we take the closest examples and then start tweaking it to suit our needs. The second is a very important observation, because unless your code is extremely buggy, usually you write it only once. But there's a huge chance that that code will be read many, many times. The very least, if some of your peers are doing code review. So if you talk to a lot of experts, they will say that your code needs to be readable, your code needs to be consistent, and it has to be crystal clear. This is where usually we say, thank you, Captain Obvious, because definitely this is what we all want. The question is, how can we achieve that? So in the next 30 minutes, I hope I can show you that there are 3 strategies that we can use to achieve a good and optimal API. The first one is about static polymorphism, to ensure consistency. And for the second part, I'll show some of the dangerous shortcuts that we tend to take that will cause inconsistent API. And last but not least, we're going to see some of the style of API that doesn't lead to readable code. So without further ado, let's talk about static polymorphism. Here we have a user interface that consists of several radio buttons and checkbox and a button. Hopefully this example doesn't make you more hungrier than you are already. So if we set the labels that corresponds to each element, and they have different values, they have different property names for radio buttons and checkbox and push buttons, it will be all confusing. For radio buttons, it takes it from value. For checkbox, it's an option. And for push button, apparently you have to use caption. Now, I line up this example so you can immediately see that there are some inconsistency there. But in many cases, it's not always obvious. Once you see that, it's rather easy to fix the problem. We need to choose the right or the similar property names for all those text labels. Another example would be a slider and progress bar. They are very similar. You have the minimum value, you have the maximum values, and you have the current values. But if the API is designed badly or in isolations, you will have a set of property names for slider and the completely different values for a progress bar. Here's bad examples. To set the range for a progress bar, you use a range array, but apparently you have to use two different properties for the minimum and maximum value respectively for our slider. Once we spot this, it's also obvious to fix this. Here's another example. So static polymorphism doesn't stop only at property names. If you need to move a point, and then you have to use a function name called translate, and apparently to move a rectangle, you have to use translate by, then there's some inconsistency there. Those points and rectangles, they resemble the same shapes in theory, and therefore there should not be any difference as to how we move them to different positions. Again, the fix is rather easy. So it's very important when you create new objects, when you want to invent new property names or function names, look at the existing code and see if there's any similarity or pattern that have been used all over the places. Here's another application of static polymorphism to function parameters. We can define a rectangle by its corner, top left positions, and its dimensions, width and height. So one way to do this is to create an object point that resembles the corner, and another object size that defines the width and height. And then we can create the rectangle using a constructor that accepts those objects. However, it's tedious to always constantly create point and size every time you want to create a rectangle. So one way to solve this problem is by having a secondary or additional constructor that accepts all set of parameters. Can anyone spot the inconsistency there? I'm sure you can. So apparently, the second constructor accepts the form of the set of values that in the form of xy1y and x2y2. So it doesn't represent top left position and width and height. It represents the top left position and bottom and right. The fix is rather easy. When you invent the second constructor, always takes into account that someone will have seen the first constructor and will have guessed that 10 and 10 here correspond to the top left, which is correct, but 70 and 50 should be a dimension, just as if you would have created the rectangle by using a dimension object, a size object. On the left side, use x1, y1, x2, y2, which is inconsistent with the previous rich object creations. On the right side, we keep it consistent and predictable because everyone knows that those four set value will be similar, like a pair of point and size. This is the moment where I need to explain a little bit the strange thing about nan. Nan stands for not a nan. Technically, it's not number. You'll see why it's not like that. So if you create nan, and then you call its nan function, it will return true, as you expect. But if you compare it to another nan, it will say it's false. That's why every year I always tweet that, nan actually stands for not a nan. For ES7, I propose that we have another type that is not the same as nan. How many of you here is a fan of Indian cuisine? So we need to invent garlic naan. So those are about static polymorphism. Next time you find that you need a new object, new names for function and properties, take a look at the existing code and see if you can reuse the same names. Assuming that you all got the names correctly, what's the next steps? So apparently there are a lot of shortcuts that doesn't allow us to get a good API. So let me remind you of this very nice questions from Juliet as they discussed the Romeo name. What's in a name? That which we call rose by any other name would smell sweet. So it is obvious that Romeo and Juliet are not JavaScript programmers because names plays an important role here. An example. Anyone here still remember Symbian, S60, Nokia, the good old days? So if you program using a Symbian API, or rather in this case S60 API, you can instantiate a component or a widget that can render a web page. This day, casually, we call it WebView. You know about iOS WebView, you know about Android WebView. Back then, it was called BRCTL. There's not even vowel there. I don't even know how to pronounce this. CBRCTL interface class reference. That is very mouthful. Apparently, you also only save, 2 letters by shortening it to BRCTL. The biggest offense here is DOM event, because instead of creating an object and then populate it, we can definitely create a new keypress event in one line of code. Keypress true, true, no, no, false, 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 9, 0. If anyone can recite what those values means, respect. My favorite is Boolean trap. Anyone heard about Boolean trap before? All right, that number should increase next year. So here's the thing. When you create a slider, you only have 2 choices, right? Either horizontal or vertical. Anyone ever seen diagonal slider here? When we have 2 choices, the obvious choice, pun intended, is to use Booleans because you can either choose true or false. So apparently, if you create a slider using a new slider true, it means that the slider is horizontal. And if you create a slider with the false in the constructor argument, then it means it's vertical. Looking at this code, it's impossible to deduce which is which if you don't have your documentation handy. It's easy when you write your code because obviously you need to read the documentation or take a look at that. But if you're outside your IDE, you're doing code review, you try to understand what the code is doing, there's no chance that you can get this right. Usually it's always 60-40 against me. The solution is to invent or to create the option object that allows you to inject some sort of property names that signify the orientation of that slider. This is just one solution. Another solution is not to accept any argument at all, and then you can have a property that changes the orientation. Boolean values in a constructor is a bad idea. Adding Boolean parameters to an existing function is equally bad as well. So let's say you have a rectangle here as part of your UI. It could be push button, it could be anything. And then you can enlarge it. You can change its size. So because we're fancy, HTML5, CSS in 2014, we also want to animate that transition, that size change. So we add new property, new Boolean parameters. If the value is true, as the rectangle enlarges, it will animate. So it will not have a sudden change of size. And if you don't want to have animation, then you can have false. One of these values could be the default values. So far so good until you need to read the code. Because if I see resize 250, 150 true, I would never associate true with animation if there's no comment saying that. Even more confusing if it says resize 250, 150 false. Does that mean please don't resize to this size? Again, one possible solution is to have that as an optional object, and in that object, you can enumerate all the possible properties that modify this behavior. As I mentioned in my previous slide, if one Boolean is bad, 2 makes it really, really bad. The more, the merrier. Now you see why it's confusing, because the first one apparently tells the tree item to collapse or expand, and the second one, while it's expanding or collapsing, please do the animations. So if you see set state true and true, it means expand and animate. If it's false, just expand, don't animate. So the last 2 examples are equally confusing because you don't know what does the code says. Does it mean set state to true and then false? It's all confusing. It's like having a double personality. You're not really sure which one is which. So even great programmers such as John Carmack almost fell into the trap of these convenient shortcuts. So what chance do we have? And therefore, we need to be extremely careful. Say you get all the consistent names, you avoid all the traps. That doesn't mean that we're done. So there are still practices that lead to ambiguities. Double negative is one of my favorites. This is especially troublesome if you're non-native speakers. Instead of saying disable false, or set hidden true, or case insensitive true, why don't we just say enable equals true, or set visible false and case sensitive false. If someone wakes you up in the middle of the night and asks you, if case insensitive equals true, does that mean capital A equals lowercase a? That's going to take a while. We also use to speak in terms of the existence of things, not the lack thereof. For example, instead of saying 20% translucent, you should rather err on the side of 80% opaque, because that's easier to understand. Same thing with the property names. Opaque and opacity delivers much more message than being translucent. Another problem with certain choice of functions is because it doesn't tell us anything about the actions. Message can be a verb, can be a noun. If you really want to say that right now change the status message to something, then you should use the construct that it's an explicit action. Same with forward and backward. Go forward is clear, no ambiguities. Same with go backward. Conversational style is something that we should avoid as well. If you have a calendar widgets and then you want to set the range for the calendars, it's easy to pick the names like year from, year to, but technically that's not what you mean. What you mean is the range, which is the minimum and the maximums. So every time you have this construct that says noun, from, to, or any kind of range, then take a look at that and see if you can rewrite it so that it makes more sense. Same with this. If you may introduce yourself by this conversational style. How are you? Please call me Adam. My flight is from this to that. But really, what you want to say out loud is the name of this person is Adam. The departure airport of my flight is this, and so on and so on. So you have to really form a proper sentence using those words in that code and see if that makes sense. JavaScript has several functions that you can use to extract portion of string from a string. You have sub-str, and it accepts the first index is the location of the portion of the string that you want to extract, and it starts with how many characters you want to get. No, in this case, I don't even remember it anymore. It's the proof that this is really confusing. So in addition to sub-str, we also have a substring. Oh, yeah. So sub-str accepts the first index and the number of characters. Substring, however, accepts first index and the last -1. If you see the first examples, obviously, if we change the location of, if you switch the position of 6 and 9, then you'll have different strings that you extracted. On the second, because it's accept indexes, not index and length, substring is smart enough to internally swap the values if you try to extract from something that is larger from the initial index. It doesn't stop there. Apparently, there's also slice. So slice works exactly the same like substring, except that it doesn't automatically swap the parameters if the first one is larger than the second one. So if you try to extract strings and you choose the wrong one, the result might not be what you expect it to be. The same thing happened with array. How many of you here got confused by slice versus splice? So slice works very simple. It just takes 2 arguments and slice your array. The original array is left untouched. In this case, A still has 3 parameters. Slice returns a new array. In this case, B. If you choose to use splice, however, not only it returns a different new array, because the second parameter to splice indicates how many elements you want to take from that array. The original is also modified. In other words, if you mistaken one for another, you might have a side effect that will be very, very difficult to debug. This is the case where we cannot see explicitly which one is mutable and which one is immutable, just by looking at the function names. One practice that a lot of people use to adopt is by having a significant or explicit action in the API itself. So if I have p new point 14.3 and I said p translate, or if I have a string and I call trim, the actions there, translate and trim, may cause some confusion as to, does that mean, my original point or my original string is modified? In order to work around that problem, we can have another pair of functions, or we can have a pair of functions. The first one is the verb present form that does modify your object. And the second one is in the past form that returns a new object. So in the case of translated for, I know that P never changes. Translated always return a new point. That is the translated version. The same thing with the second example, where trim just remove all the spaces in my original string. But if I call trim, then I know that my original string is left untouched, and I have new string. That is the trim version. So once you manage to achieve consistency, avoid shortcuts, and then choose the right API that reduces ambiguities, how can we ensure that we don't need to do this kind of review over and over again? So there are several best practices that is often recommended. The first one, make everything private by default, because as soon as it's out, it's very difficult to take it back. There's a very nice story about this function called h-strip mnemonic, and except that there's a typo there. It's a long story, but basically it falls into the category of it was private, nobody pays attention, now we need to make it public, and it falls through the crack. It's basically like toothpaste. When it's out, you don't want to take it back, or even you can't do that. And if you want to make it public, you have to justify it. And the way to justify it by writing 3 examples, totally different examples, not the same example, repeated 3 times, that use the API. This way you can have a solid argument that, okay, I make this public because apparently there are 3 different use cases. So don't make it public. Make an API public unless you write 3 examples. Unit tests, they don't really count as examples because you may just repeat the same pattern over and over again. And you need to have API review, just like you have code review process. You can collapse this at the end once you want to make your library application public, or when you need to interoperate with other modules. It's my philosophy that I'm going to fail my first 2 attempts anyway, so better to make it really quick, really painless, and then hopefully 3rd time's a charm. The mandatory API review is also your chance to, prevent anything bad happening or going out. Can anyone mention all the wrong things about this poster? And last but not least, anything that can be done by the machine should be done by the machines. So this is what separates us from the Neanderthal JavaScript programmers. They don't exist anymore. If you don't believe me, look left and right. You don't see them around here. If you tend to write or make some comments about APIs over and over again in your pull requests, comments, review, etc., then it's probably about time to make it automatic. So let's talk about API Detective. This is a set of tools that empower you to build a set of rules that detect strong use of API. We know that we are bombarded by all this kind of testing, whether it's TDD. Anyone practice TDD here? BDD, and at this rate, I'm not surprised even PDD is involved in our testing workflow. But the question that you should ask yourself is, what do we test? Do we test the right things? Do we only check the behavior of the function? Do we also check the style, the API, the choice of words, and so on and so on? So the weapon that we can use to do this is by having a syntax parser. A parser will consume your code, and first it will tokenize it, split it into certain tokens. In this case, var answer equals 42. We know which one is keyword and what is the identifier and so on. And then it will build the syntax tree that resembles more or less the syntax of your program, as the name implies. You can create this syntax tree and then display it in the form of, in this case, JSON. Or you visualize it just like a normal tree. Now, once you have that, you can get a lot of information. For example, I can have a syntax parser that consumes the tree, walk the tree, and then extract all information from my application. In this case, I can have the metadata of my applications. What are the object, what are the function and properties in that object or modules? What is the name of the modules, and so on and so on. The collection of these function and properties are very good, very powerful, because then you can apply certain, for example, blacklist. If you don't have double negative, then you can search for those double negative in the function or property names. This is the simple examples to collect all those member expression. For example, is this sort function to check for Boolean traps? What it does is to parse the code, get the syntax tree that corresponds to that line of code, and then we all know that if I have reload x, y, false, then you will see on the left side the syntax tree shows that there are 3 arguments. The first one is x, the second one is y, and the last one is a literal value false, which is a Boolean types. And that's what you can catch in your program. As I mentioned earlier, you can also blacklist all kind of names. Again, the way we do it is from the syntax tree, we will get the callee, and then we will look up the identifier. In this case, it's set disables. And then you can compare set disables to a list of all blacklisted function names that should not be used in your application or library. In the future, hopefully, our tools will be so advanced that it can detect all kind of craziness. For example, if you call a mutable function, but you never use its return value, usually it's a mistake. You think that function is mutable, but it's not, and therefore you don't do anything with the return value. Or something that is very common in the security world, where some function is being called a gazillion times, and you always check the return value, but there is one spot where you don't check any return value at all. Is that intentional, or is that an honest mistake? So, as a wrap-up, practice the rituals of base API, use static polymorphism to ensure consistency, and if you take shortcuts, be judicious, and to avoid ambiguities in your API, read out loud, and choose the property names that do not propagate that ambiguities. Make sure you build your tools, because we have limitation, we are just humans, and of course, apply all these best practices. My name is Arya, I work for Safe Security, and if you have questions, you can come to my office hour at 1:30 or come on stage and we'll have discussion. Thank you very much.